Okay, so welcome everybody to session 7, which is focusing today on groundwater characterization and conceptual model development, which is my personal sort of something that I value the most in any groundwater study. What we're going to go through today, we'll just go through the schedule for the rest of the mentoring program, why we do groundwater characterization, why it's important, then the data types that we work with and collecting these and looking at these data types, and then finally conceptual model development and any questions. So the schedule, the one that I've sort of planned here, and you guys must give input here as well. Today we're doing groundwater characterization. Then Thursday the 13th of August we'll go through groundwater modeling, the process, selecting the type of model that you're going to use, and then compiling your report, going through the modeling process as well. And then 27th of August, we'll do groundwater in mining. So the mining life cycle, the different types of mining methods, groundwater in the mining operation, and then groundwater mining in the environment. In September, we'll do monitoring network design, monitoring program design, and then groundwater management plans. And then towards the end of September, we'll go through specialist groundwater applications. You know, one of the queries we had in the last session was to do underground mining and tunnel interaction with groundwater. And if you guys have any suggestions on like a specialist application for groundwater studies, then just let me know and I'll include it in that session. And if there's any other kind of aspect of groundwater study you'd like to cover, just let me know and we can plan around it as well. Okay. So why do we need to do groundwater characterization? Now, groundwater characterization forms a critical part of all groundwater studies, as it provides a baseline for all further work that is to take place at an operation or a site. Good characterization study informs your scope of work selection. So your characterization will tell you if you need to do additional geophysics, additional drilling. It'll help identify the gaps in your existing databases, those kind of guidance things. And also if you don't need to do something. If the data exists and you characterize your site well enough, you might not need to do any additional work. Groundwater resource development feasibility, where if you characterize your sites and you find that groundwater resources are not feasible, then there's no point in proceeding with the project sometimes, if it's a resource development project. Then also groundwater management requirements. If you find that your site is particularly sensitive or vulnerable, such as a caustic aquifer system, additional groundwater management is required to protect that aquifer system, and that you pick up in your characterization phase of the project. Does anybody else have any applications of groundwater resource or groundwater characterization? Where would it be important? No one. Okay, we'll carry on then. So the data types, the collection of this data, and then the data interpretation that we typically encounter. This is not an exhaustive list. This is just the typical ones that we use in groundwater. So can anybody tell me the difference between data and information before we go through this slide? Does everybody know this?
Matthew?
Hello.
Wouldn't data be like your numerical values and yeah, spreadsheets, your Excel spreadsheets and stuff like that, and information. Would information be like the reports that you find on the internet or something?
Exactly. You know, your data is a collection of raw facts, measurements, or experimental results. You know, like you say, your Excel spreadsheets, your raw data, your observations, etc. And then information is where that is processed and organized to give it context. You know, a series of numbers could mean anything. It could be water level measurements, it could be temperature measurements. So until you give it a context and interpret it, it's not adding value to your overall study. So you see, information is created from data. You've got processing in the middle between your data and information. So the types of data that we collect for site hydrogeological characterization includes the following broad categories of data. We've got topographic data, climate data, hydrological data or surface water data, geological data, and hydrogeological data, of course, which includes your groundwater levels, groundwater quality, and then groundwater abstraction data, if there is any. Geophysical data, if you have it. Geochemical data, and then site development data. You know, site development data is your layout plans, your construction plans, your mine expansion plans, all of those kind of things. So topographic data gives you a general site setting. And this kind of data includes topographic maps, your rivers, lakes, and dams, your regional surface elevations. You know, typically, you get it between 5 and 25 meter resolution in your SRTM databases and your chief surveyor databases in South Africa. If you're lucky enough, you'll have site surface elevation, which is typically localized to the site only, but there you can get your LiDAR data that's up to millimeter accuracy in some cases. And then also land use maps. And topographic data helps us to identify potential boundary conditions for our groundwater system. So it's your topographic highs, your perennial rivers, you know, those kind of features, your quaternary catchment boundaries that you'll pick up in your topographic data. Recharge zones based on your land use. If you've got cultivated land where the soil is disturbed versus urban land where you've got concrete and tar roads over your soil, you know, those are going to be different recharges. And then areas of potential groundwater surface water interactions, you know, your lake areas, your perennial rivers, big dam compounds, you know, those kind of things you'll pick up on the topographic maps. Climate data, you typically only use rainfall and evaporation. Yeah, unless you're in an area with permafrost, like maybe some areas of Lesotho, but more like America, North America and Europe that worries about temperature. The temperature doesn't, it's nice to have in your report, but it doesn't add too much value in terms of groundwater. So if you can't find it, don't put it in, don't stress about it. Your climate data aids you in determining your seasons at the site. Is there a clear wet and dry season? Yeah, which helps you in discretization of your time if you're doing a model. And then your mean annual precipitation and evaporation from the site, of course, which is important for determining your recharge. And then you get correlations between your rainfall and water level or concentration fluctuations. You know, sometimes you'll see your water level will fluctuate about 5 to 10 meters between the wet and dry season. So that helps you determine what's a normal fluctuation and what's an impacted fluctuation in your water levels. You see here, we've plotted your rainfall in the bar graph, the baseline water level here. So you got this declining trend there, and then you got a big increasing impacted trend here. As you can see, during rainy season, you got this fluctuation of shallow water level, and it goes down in the dry season. But then it just goes all the way up. Yeah, that's from the tailings dam that was installed right next to that borehole. Okay, hydrological data or surface water data. That's quite important where you've got rivers that take base flow or streams that have a source as a spring. Yeah, anywhere where there's surface groundwater interaction potential. Yeah, the data that's useful to us is river hydrographs, the dam and the dam or lake water levels, the bathymetric surveys showing how deep the dam is. Yeah, we very rarely get that unless it's a specific study for a pit lake or something. And then your river, dam or lake water quality information to see if your groundwater is being impacted on by the river or the groundwater is impacting your river. Okay, and then there's just the Piper diagram. What we do here is you've got your borehole. Can everybody see this Piper diagram?
Yes.
Okay.
Yes.
Right. So one of the ways you look at your surface groundwater interaction is you look at your chemical signatures on the Piper diagram. So you can see the borehole is the circle, then the tailings dam is a square, and the river is a triangle. So from here you can say the tailings and the borehole have a similar signature, but the river is totally different. So it's not likely that these two are interacting with the river. So that's just like I said, it's not conclusive, but it does give you a good indication if they are talking to each other and interacting. Okay, geological data, you look at your regional setting and the site localized setting. They're quite important in establishing your initial conditions and what your hydrogeological setting could be. And typical geology data sets that you look at is your regional maps, your 1 in 250,000 or 1 in 500,000 maps. The site-specific geology and structural geology maps, if you're lucky enough to have that. Drilling logs from your drilling campaign and from exploration drilling campaigns. And then geological models, if you have that. You know, typically on the mines, or most mines except for your coal mines and then the limestone mines will have a geological model of sorts. And finally, the most important one would be your hydrogeological data. Obviously, because we're doing groundwater characterization. This, we look at our hydrogeological maps, the previous specialist reports for the region and for the site, and then literature available for similar geological terrains. When you work at a site where there's not a lot of existing information, you can look at reports in a similar terrain. So if you're looking at a mine or a site that's in a greenstone belt, but there's no previous studies for your area, you can look at other greenstone belts that are similar geologically and sort of climatically. And you can deduce, you can sort of infer from those reports, you can say this area has this kind of characteristic, so this is expected to be the same at this site. And then more site specific, you're looking at your water level monitoring data, water quality level or quality data. And then if there's any pumping boreholes, you look at the abstraction data. Do you get more out of the borehole in summer versus winter? Any trends in the abstraction data will help you characterize your site as well. This data you should interpret to give you information such as the aquifer type. Is it an intergranular aquifer? Is it a fractured aquifer? What's the dominant type of aquifer as well? Is it confined, unconfined, geoporosity? That kind of information needs to come from these interrogations. Your depth of the aquifer, where it starts, where it ends, how thick it is, what its extent is, its vertical extent, lateral extent. And then your average hydraulic properties, if you can get that. What is the expected conductivity? What's the expected storage? Then existing groundwater use in the site region. That helps you identify the potential, number one. And then number two, your sensitive receptors, if your site is going to have an impact on anyone. Yes, Lingiwe?
Hi, Matthew. I'm sorry. I think I might be taking you back a bit, but like groundwater characterization, does it mean when you have collected everything and then now you're trying to make meaning out of it? Like, so when you collected all the data and then you're trying to make meaning out of it from what you have, is that what it means? Because I don't think I get what it means.
Well, it's characterizing your site. Is it a productive site? Is there receptors there? It's your desktop review. It's giving you a picture of the site from all of your data sets.
Okay, so basically it's taking everything and putting it together and making meaning out of it.
That's it. You'll see we're going to go, at the end, we'll go through the conceptual model.
Okay. Thank you.
Popelo?
Matthew, I want to ask, with the graphs here, the water level fluctuations, how would you interpret this graph? Because I think it's the same as the one you gave us in task 2, I think. I don't really understand this graph and and how you constructed it and all of that.
Okay. This graph is just a water level fluctuation graph. That's a box and whisker plot. So you've got your minimum there, your 25th percentile or quartile, and then your median in the middle there, and then 75th quartile, 75% quartile, and then your maximum here. So it just shows you the spread of your water levels. That just shows you that there's no real outliers in your data. Whereas if you look at your nitrate concentrations, there's a massive fluctuation there, which is potentially a bad laboratory reading or something. So these are box and whiskers. This is just statistical plots. Yeah, the one for the task 2 is a different kind of plot.
Oh, okay.
Okay, so this just gives you your data distribution. So you can see in the groundwater levels, there's no real deviations. It's quite a narrow spread. But with your nitrates, this one's got quite a broad spread. This one's got a massive one going down to your minimum value. So it just gives you a good idea of what your data set is looking like.
Okay, thank you, Matthew.
Cool. Can I carry on? Or is anybody else confused about what groundwater characterization is? No. Okay, so I'm going to carry on then. You'll see we'll go through the conceptual model at the end and you'll see what everything comes down into. And then your geophysical data, you're going to have either your surface geophysics, like we've discussed in the previous sessions, or sometimes you'll get downhole geophysical data as well, like in this picture here. You've got your acoustic televiewer picture, which is like almost a camera. Then you've got your directions of your fracture zones, etc., on the calipers. That'll give you a nice idea of what the fractured zones look like in a borehole. Your surface data will give you an indication of your potential aquifer depths, how far your aquifers are, and then also any geological structures that will act either as a preferential pathway or a barrier to groundwater flow, such as your dikes and sills, big fracture zones, etc. And like I said, downhole geophysics can give you an insight into subsurface conditions, such as your fracture structure orientation, the aperture of your fractures, how big the fractures are, and then also your general structural orientations at the site. In geochemical data, that's typically reserved for like your acid generating mines, such as a coal mine or a gold mine. You know, where there's a contaminant of concern, you'll do a geochemical study. So where you've got somewhere that's got a waste rock dump that might be leaching contaminant into the groundwater system, you'll do geochemical reviews just to get initial concentrations of your contaminants and the evolution of that concentration over time. Your common geochemical data sets include your kinetic and static leach testing results, acid-base accounting, geochemical modeling results, your Pyrex model on the coal mines, your mineral analysis results, and then your sulfur speciation tests. So this is what in a closed mine, you'll have your backfilled pit here with your dumps seeping into the groundwater system, and then also your pollution control dam. And then over time that evolves as you get your rebound. You know, this will go through a bit more detail in the mining section of the mentorship program. And if you're doing an impact assessment or a water use license application, it's very important to have your site development data. This gives you it's your layout plans. It's how big is the mine going to be? How big is your building site going to be? What's the size of your agricultural project? How big is it now? How big is it going to be? And then also the schedule. How long is it going to take? And then when are they doing what? That helps you determine your groundwater impacts, what you need to look for if they're doing building in the dry season versus the wet season versus the whole year round. All of these things play quite a big role in developing your characterization of the site. So you can see here's a mine plan where each color is a different year of mining. Anybody that's worked with a mine plan before will have nightmares about all these colors. It looks like an oil slick, but that's what you'll get from the client. And that's important because if this is dipping, going deeper that way, you need to take into account what your groundwater system is going to do. Is it going to be completely dewatered in time? Are you going to impact the neighbors? You know, all those things to plan your study accordingly. Okay, so I just wanted to give you guys a quick overview of the types of data and then what we're going to look for, some of the analysis methods, and then your software requirements. So with the topographic data, you're going to look for rivers. Is there a perennial river, a non-perennial river? What's the dominant land use in your site area? Is it mostly agricultural? Is it urban? Because those all have different hydrological cycles. And then you look at your regional and site-specific elevation data, just for your no-flow boundaries, etc., where your general flow direction might be in surface water. Those are all visual analysis, so you look at the map and you see if it's there or not. And for that, you'll need a GIS package, such as QGIS or Global Mapper, one of those. Climate data. Look at your mean annual precipitation or evaporation. Monthly distributions of precipitation and evaporation. This first one, you calculate your mean in Excel. And the second one, I like a column graph, just to give you a monthly distribution in Excel. Hydrological or surface water. What's important is the base flow, so that you can either get directly from a database such as the WR 2012 in a GIS package, or if you have river flow data, you can do a hydrograph separation in Excel. Has anybody done a hydrograph separation before?
Nope.
Have you been exposed to it? Or is it a totally foreign concept?
I've heard of it, but yeah.
Okay. Okay, no, then I'll include it in one of the next sessions. I'll just get some examples. I just need to find a nice data set. So we'll look at that. And then your seasonality of the bodies. Like, is it a non-perennial? Is it in flood once every 10 years, or is it constantly flowing throughout the year? These are important things that you need to look at. And that, again, will come from your database or your GIS data set. In geology, you need to look at your dominant rock type, get that from your maps. The geological complexity. Is there 10 different units in your 10-hectare site, or is it just one big unit like we get in the Karoo formations? This helps you get an idea of how complicated your aquifers might be. Geological structures, both open and closed structures. And then your weather depth, which you'll typically get from your database, your drill database. It's either in GIS or Excel. And your weathering depth is important for your recharge. And your storage of water. If you've got a shallow weather depth, you get a little bit more runoff in general. Okay. So now the important one, your hydrogeological data, your aquifer types, aquifer yields, and your aquifer extents and complexity, you'll get from your maps, your databases, your WR 2012, your hydrogeological maps, even your geological maps. And to, like a rule of thumb with your geology, if you've got unconsolidated or weathered geology, you can expect an intergranular aquifer, same as with alluvial sediments. In South Africa, your sandstone, shale, and igneous rock generally gives you an intergranular or fractured rock, fractured aquifer, sorry. Your igneous rock usually leaning more towards a fractured aquifer. Metamorphic rock is almost always a fractured aquifer type. Quaternary deposits, such as your sand deposits or your aeolian sands, is an intergranular. In dolomite or limestone, you can either get a caustic aquifer or you get a fractured aquifer. Now, dolomite is not always caustic. Competent dolomite has got almost zero yield. It's like it's tight. It's difficult to drill through. So it's not always, just be careful of this. If you see dolomite, don't immediately assume cast. Look at it carefully. Okay, so aquifer parameters. There's various ways of determining your aquifer parameters. You can do a literature review, or you can do interpretation of data sets if you have it in Excel or Equity Solve. Groundwater level trends and fluctuations in Excel. A lag effect in recharge. That's where if you get rainfall in September, you only see a rise in water levels in December or January. Most of the time you'll have a 3-month lag period. And then this is your parameters here. Just to go back 2 steps, sorry. So your recharge you'll get from literature, or you'll calculate it using water table fluctuation or chloride mass balance methods. Transmissivity you'll get from literature, pumping tests, sieve analysis. If you have that data in a geotechnical study, you can use the Hazen formula and calculate conductivity there, or permeability. Storage or specific storage, we typically get this from literature, or where you've got an observation borehole during your pumping test, which is a borehole that you're not abstracting from. So it's like a neighboring borehole or something. That's how you can get your storage values. Specific yield, also typically from literature, but you can get it from a sieve analysis. Effective porosity as well. Typically we get it from literature, but you can get it from a sieve analysis or a laboratory experiment. Everybody happy with these sources? Do you know of any other sources for these parameters? Nobody. Okay, so we'll take that as the only place you can get this data then. So your surface groundwater interaction, typically you'll have a sample from a surface water body and one from a borehole. You can plot it in your Piper diagram just to see if they've got a similar signature. The software that I use is Groundwater Chart or GW Chart, which is a free program available from the USGS website. If you want something more conclusive, you can do isotope studies for surface groundwater interaction. But typically, Piper diagram gives you enough of a hint to say there is interaction or there isn't. Then your water quality evolution, you get from your Piper diagram or a trend graph. Sources of contamination, typically you'll see a nearby monitoring point will start to show contamination after you've constructed your tailings dam or waste rock dump or whatever facility you're looking at. And groundwater abstraction volumes, you want to see, is it maintaining consistency or is it losing capability over time? Yep, Boipelo?
Sorry, Matthew. I think the recharge, right? I think you can get it from the Water Research Commission, the WR 2012 data set, the GIS data. I think they also have it there.
Yeah, I think it is I think they've got 3 different shapefiles. I think they've got the Vector. Then I think there's one, I think it's a Pittman or something. And then they've got the one that's assigned per quaternary catchment. They've got like a recharge estimate. But you're right,
Yes.
WR 2012. It's a very nice database.
Yeah, it's very nice. It has most of the data sets, a lot of them.
That's the thing. I mean, it's got all the hydrogeological maps for South Africa are available in that database. Yeah, it's a vector shapefile, which is a lot easier to work with.
Yes, definitely.
Yeah, great. So thanks for that. Anybody else have any other sort of sources of the aquifer parameters here? Something that you've come across or, yeah, Antonia, literature? Yeah, a good starting point for this is always, obviously Google or whatever journal databases you have access to. The WRC, Water Research Commission for South Africa, that's good. The SADC databases for Southern Africa. Yeah, there's a lot of nice websites to get specific information and then also just for similar geological terrains. And then this is just a repeat of what I showed you guys in one of the earlier sessions. These are nice sources of information. For your climate data, you can get this world database. That's got it's grid information for the entire world with monthly rainfall values. This world climb. And then SRTM is a good data source for topography information. WR 2012, which we've just spoken about. You can download the shape files. And I don't think it's terribly big. I think it's 700 megs, if that much, to get the entire thing. Your Department of Water Affairs, they've got a hydrology section where you can find river base state or river measurement stations per river across South Africa. And most of them have flow measurement data, daily and monthly averages. So you can do your hydrographs. Regional geology, there's a 1 in 1 million free database available at the council website. Geophysical data also available for South Africa from the council website. And then again for hydrogeology, I would recommend starting at the WR 2012 and then working your way to National Groundwater Archive when that starts working again, and your previous site reports, your hydrocensus investigations, etc. So keep this as like a little cheat sheet for you guys. If you ever want to look for a specific data set, you can just look at these links and go from there. I might just include them. Yep, Papelo?
I know, like during my honors, right? I know with the climate, the annual evaporation and precipitation, we use the rainfall data from the Department of Water and Sanitation, and we had to like literally calculate the monthly precipitation from the data that we had. So I was also wondering if the world climate data, is it like your recent data? Like is it updated like daily or annually, or yeah?
You see the World Climate, they've got two data sets. They've got historical, which is averages for, I think it's 30 years worth of data. And then they've got future projections from 2021 onwards. I know what you're talking about on the Water Affairs website. You get it from the hydrology section. But I've seen lately that they got like an overflow error in their database. So you can't download all of the stations. Yeah, the database can't pull it up for you. So you can only, like I've only been successful with Water Management Area A to get data from them.
Oh, okay.
But I agree with you, the DWS hydrology, you'll see it has a tick box that says, I think it's meteorological station, and you can search for that per catchment.
Yes, it is.
Okay. Is everybody comfortable with the data analysis and the kinds of data that we use and that kind of thing?
Yes, thank you.
Great. Any questions up to here before we get into the conceptual model? Nothing. Yep, bonjour.
Hi, Matthew.
Hi.
I just wanted to ask what extra management requirements are needed for karstic environments?
Well, typically you'll need to protect the surface a bit more. You got to manage your spills. You got to limit spillage, because if you've got a karstic environment, you've got like a direct flow channel from any spillage on surface into the groundwater system. You've got to manage your dewatering as well a lot more closely, because if you dewater a cave or a karstic cavern, you get the risk of sinkhole formation, etc.
Okay.
And even just drilling, if you drill through a cavern, you've got the potential of collapse, and you risk your drilling equipment, etc.
Oh, okay.
Okay, so it's all the risks that they outline in the, I think it's council, it's either council or water affairs that have the guidelines for development on dolomitic land, and that highlights all the risks that you need to take into account.
No, okay.
Okay. Any other questions before we go on? No. Poncho?
Sorry, I also wanted to ask, you said Lesotho has a permafrost. What is a permafrost?
It's like subsurface ice. Yeah, it's where the soil water has become frozen. It's only in
Oh,
like high up in the mountain areas, but it's more in Canada and Germany and Siberia, those kind of places that you deal with it.
okay.
Yeah, even in Lesotho, it's very localized and it's seasonal as well.
Okay.
Yeah, it's just these
Thank
things you
you.
have to you have to talk about it just in case someone does find it somewhere.
Yes. Yes.
Okay, so we'll carry on with the conceptual model. Yeah, for me personally, a conceptual model is one of the most important things in a groundwater study. This helps to cement your findings and your understanding of the groundwater system. And it's also what you refer back to. You know, if you see something strange in your data set, you can refer back to your conceptual model and say, is my conceptual model wrong, or is this suspicious data? You know, if you do a pumping test and you all of a sudden have a yield of 100 liters a second, but everything else says it's 5, yeah, then you can inquire your data set. And if it's wrong, fine, then you have to go redo it. But if it's right, then you have to redo your conceptual model. Just remember that a conceptual model is not final until you submit your report. If you find data that you need to update your conceptual model, go back and update it. So the aim of the conceptual model is to describe the topographic, hydrological, geological, and hydrogeological environments and to quantify their interactions. So what we need to do is compile all of our site-specific regional data into a central data set where you apply simplifications and concepts for that system to be represented into the model environment. Yeah, that's in the ASTM guidelines for groundwater flow model. You see, what we do is we take this area here where you got your open cast mine with different geology units, slowly but surely simplify it. You've got your area of artificial recharge with your weathered zone, main aquifer, and then basement. And then when you're doing a numerical model, you take that next step and you just put it into the different layers. So that's the objective of our model, the conceptual model, is to understand our system well enough to simplify it. Does that make sense to everybody?
Yes. Thank you.
Yeah, great. It sounds strange that you understand it to simplify it, but you try to simplify something that you don't understand. Yeah, you'll see just how little you understand that thing. Okay, so the data that you need to incorporate into your conceptual model is your regional and site-specific geological framework, where your lateral aquifer extends, the thickness of your aquifer, any geological structures, the confining layers. All of those geological inputs are described and quantified. The topographic data for your model domain, which includes the elevation and extent of surface water bodies. That is your site on a steep slope, a gentle slope, a flat area with a hill on one side, all those kind of things. Then your hydraulic properties for the system. Of course, your transmissivity and your recharge rates per area. Any sources and sinks for groundwater. Everything needs to be included there. Oh, sorry, that's the next point. Yeah, source and a sink. That includes your abstraction wells, which is a sink. Then your open pit mining, which is also a sink. Losing surface water bodies, where water is going from the surface water body into the groundwater system. That would be a source. And then you need to get the spatial and temporal variability of the sources and sinks and quantify those. So that's where it's important to understand perennial versus non-perennial rivers, base flow versus no base flow rivers. All of those things impact on your groundwater system, so they need to be understood and included in your conceptual model. Then you need to understand your spatial and temporal trends in your hydraulic head and the recharge rates and include that into your conceptual model. So that's what I was talking about with your seasonal fluctuations in groundwater levels. Your typical fluctuation is between 2 and 5 meters. It can go up to 10 meters. And that influences your recharge rates, which is also influenced by your rainfall data, your evaporation data, all of those aspects. So you can see how interconnected all of your different environments at the site are. Everybody happy with this so far?
Yes.
Cool. Okay, and then the questions that you need to answer in your conceptual model. Yeah, these are not, this is not a definitive list, but this is the sort of bare minimum. Yeah, have you described your groundwater flow and your aquifer flow directions adequately with the available data? Sorry, I just got a question here. Yes, Antonio, so you do include a water balance, which would relate back to your recharge and abstraction, your sources and sinks. That would be your water balance component of the conceptual model. Yeah, is my system in a state of natural deficit, which is where I'm abstracting more than what's going in? Or is it in a flooding situation where I've got more recharge than abstraction? So that forms part of the sources and sinks. Okay. So have you described your aquifer and groundwater flow directions? Yeah, do you know if groundwater is flowing through the site, going north, south, east, west, etc., from the tailings to the mine, from the parking lot to the back of the site? And then is the groundwater system 1, 2, or 3-dimensional? Yeah, that's more in terms of what are you trying to simulate. Yeah, if it's just one pumping borehole, then you can do a 2-dimensional or even a 1-dimensional study model. If it's 3-dimensional, where you've got multiple layers and multiple aquifer systems interacting, then it'll be a much more complicated model and a complicated system. And have you described your dominant recharge mechanism? Now, when I say dominant recharge mechanism, we always think of groundwater recharge as rainfall. And typically it is a dominant recharge mechanism. But in some areas, you've got a lot of surface water interaction, where you've got rivers that are losing water into the groundwater system during the dry season. And that's your dominant recharge mechanism. Or you've got a source, like a tailings dam or a storage dam that's leaking into the groundwater system, and that's your main source of recharge. So dominant recharge mechanism is not always rainfall. And I've had a site, for example, in North Africa, where we had the weathered zone. It was between 30 and 50 meters thick. And then underneath that, we had a fractured aquifer system. And the water levels in the fractured aquifer system stayed level the whole year round. But in the weathered system, it fluctuated to almost dry every dry season. So your recharge mechanism to the upper aquifer unit, the weathered unit, was rainfall. But to the basement, that fractured rock unit, it was actually the release of water from storage in the weathered zone. So that was your dominant recharge mechanism there. So just be aware that rainfall is not always the only source of recharge. And then here's just a reference for Mandel. That's a good reference to have if you want to do numerical modeling. Is the aquifer homogeneous or heterogeneous? That helps you determine if you can use certain equations and solutions for data interpretation and modeling. Most of the time we work in heterogeneous environments, but you can simplify it into homogeneous if it's an alluvial aquifer system or something like that. Are your boundary conditions adequate? Yeah, how big is your site? Have you set the boundaries of your unit of analysis? The area that you're looking at, is this adequate? Is your site going to interact with these boundaries? Yeah, like we went through the last session on Tuesday, with a sustainable yield, your boundaries need to be far away enough from your site so that the site doesn't interact with them. And we'll cover this in a bit more detail in the next session. But your conceptual model should answer this question. Is there any other, are there boundaries that are closer, or are there boundaries that are further? And have your variations in groundwater flow direction been quantified? Yeah, on some sites what you get is in the wet season, groundwater feeds the rivers. So the groundwater flow direction would be from the aquifer into the river. And then in your, in the dry season, when your water level drops, the river will feed the groundwater system. So then you've got a change in groundwater flow direction. Have you picked that up? Does this happen on your site? And then you have to make sure you've quantified it properly. So is everybody following so far with what we need to do with the conceptual model and what it needs to include and how we include this?
Yes.
Right. Kondisi?
Yes, everything's okay.
Cool. Okay, so I'm just going to show you an example quickly of a conceptual model. Yeah, this is one we did in the Northern Cape, sorry. So you've got this big layer of sand on top, and the mine drive shaft was going down there. You had these big fault zones going across, your shale zone on top, then your lava basement at the bottom. Yeah, very complicated geological environment. And then you simplify that, you trace everything there, and you've got your groundwater flow direction in the blue arrows. You can see groundwater flowed across the weathered zone, then down the fractures into this deeper aquifer units, down the fracture zones there. Recharge was coming across here, going down. Then you had secondary recharge being released from your upper sand unit, your weathered zone, going down into my fractured rock unit. And then in the model environment, we had the upper sand unit, a clay unit, and then a deep fractured rock unit, which was split into 3 different layers. So do you see what needs to be included as a minimum in your conceptual model?
Yep.
Okay, so are there any questions on your characterization studies and the conceptual model development? Yeah, Popelo?
Matthew, I want to ask, what software do you use to generate a conceptual model? Because that seems really hectic. Do you use Excel and I don't know what else?
Well, look, I mean, it's effectively a sketch. So any kind of vector drawing program, this one I did in Surfer, golden software, the Surfer package. But you can use, like the ones I draw nowadays, I use Inkscape, which is an open source vector program. That gives you a bit more freedom in terms of the color palettes and the textures that you can add. But anything that you can sketch in, if you can do lots of digitization and that kind of thing. Blender also, I've seen some very impressive conceptual models in Blender, also an open source software. So it's up to you.
Okay, but like, what steps would you take in generating it? Like, what would be your starting point after answering the questions and capturing your data? Because now I see with faults, right? If you're gonna add a fault, you must know the dipping of the fault, right? So how would you add all of that, and what processes do you follow? What steps do you follow?
Oh, look, I mean, I was fairly lucky with this one in that I had this geological section that we drew from the drilling data. You can see all of these black lines here are exploration boreholes. So then you draw your geological section and you just overlay your hydrogeological information over that. And if you don't have that, you look at your geological map and you sort of infer from there.
Okay, so do you need to produce a cross section first before generating a conceptual model?
Well, typically you represent your conceptual model as a cross section. Yeah, that's the best way for me to present or represent groundwater information is in a cross section.
Okay,
Yeah.
so Matthew, you'd first like collect your borehole data, right? Like the log and the depths of the boreholes, right? And then after that, I don't know, how do you arrange it in Excel for them to be in order? Because I've had a problem with developing a conceptual model, something that I don't understand.
Okay. Let me just get to Armand quickly, and then we'll come back to you because you say you've had a specific problem.
Yes.
Do you mind if I just help Armand quickly?
No, that's fine.
Cool. Hi, Armand.
Hi, Matthew. I would just like to add on the concern raised now as well. The problem I made in the beginning is, if you think about a conceptual model, it's not a single model. The cross-section is only one part of that entire process of conceptualizing your problem or your site. So I don't think we should make the mistake in just thinking about conceptual model as just a cross-section or something like that, because that's a mistake I see a lot of people making by thinking if you have a cross-section, that conceptualizes your site fully. So it's not specifically referring to one single model, it's your entire conceptualization of the site. So it's not like you're going to build a model that's going to tell you everything. That's just a coalition of your information. So it's very important to distinguish between that.
No, definitely, Armand, I agree with you. There's a whole report and a section that goes along with this. There's maps, there's figures. The conceptual section is just your sort of culmination of the key parameters of this. So no, I definitely agree with you there. This is not the be-all and end-all of your conceptual model. Is that what you're trying to get across?
Yeah, exactly. Exactly.
Yeah, great. Yeah, look, all of the data that we've gone through in this presentation needs to be included in your report. And then your conceptual model summarizes that and takes out the key aspects of what's important to your groundwater flow regime at the site. Yeah, so don't think just because, like Armand said, just because you've drawn a section doesn't mean you've understood your site. You need to have quantified these recharge arrows. What's the recharge value? What's the recharge interaction between your upper and lower aquifer units? Why is groundwater going down the fault and not being sort of blocked by the fault zones? All of that needs to come through in your report and your characterization study. Okay, so Popelo, I'm just going to ask you to just explain what issue you had there with your conceptual model.
Okay, so in my honors project, right, I had to develop a conceptual model before generating other models, right? So I had to use my borehole depth, and I had to use the elevation of the area, right? And in my conceptual model, I had to also include the water level and the river and where the mine is. And I was using Excel to develop it, and I found it to be very hard. I didn't really understand how to conduct and show all of those things in one graph or in one picture.
Well, look, I mean, you got to take a step back from it. Yeah, your borehole depth is obviously the depth of your area of investigation. You know, if you've only got a 20-meter borehole and that's all the data you have, that's as deep as you can look. So that sort of defines your extent of investigation in that case. And then your mine also determines the depth of your section. Then the river, you need it to say, is the river interacting with groundwater? Is it feeding groundwater, or is it being fed by groundwater? So all of those things you need it to show in your section. Yeah, in Excel, it is difficult because you sort of controlled by the numbers. You need to have an X and a Y. Yeah, that's why I like to use the vector programs, because you can draw it a little bit. You get your sketches. Every conceptual model that I've ever done starts off with a sketch, just a block sketch.
Okay, I understand.
Yeah, so that's why it's important you do your write-up and your initial assessment before you start looking at the section. Understand each individual element of the environment, the topography, the climate, the groundwater levels, the groundwater parameters, the geology, the types of aquifers. And then your conceptual model should bring all of those things together. Yeah, that's the aim of the conceptual model, is to bring your understanding of the site environments together in the context of the groundwater flow regime.
Okay, so is there like a right and wrong conceptual model?
That's difficult to say. I mean, you've got a conceptual model that's not defendable. You know, if you draw a picture that says groundwater is flowing from here to here, and I say why, and you say no, because I feel like it, that's not a good conceptual model. And also, if you're not defending and not justifying what you're saying in your conceptual model, then it's not a defendable conceptual model. It's difficult to say if it's right or wrong, but it's not defendable.
Okay,
Sorry, Matthew, if I can add on that.
Mm.
So like I said previously, the conceptual model is just a coalition of everything you know. So the scope of your work, everything you've developed thus far, that's what your model represents. So it's actually a tool to identify the gaps. So everything you know, all the data you've gathered, you put into the model, or you create where there's a picture or a graph or whatever you create. That just gives you an idea of what you have up to date. So your model will essentially be right if you are just using your knowns, your known data, your known values. So your model should be correct, and then you just build on that model by identifying your gaps. So your model should essentially be correct if you use the data that you know.
Exactly, and if you've interpreted it correctly, if you've put it into the right context.
Okay, I understand. Thank you.
The problem with, this is a science, so you have to follow the scientific method. Your conceptual model is a base for most of your other investigations. So typically you'll build your conceptual model at the beginning of a numerical modeling or an analytical modeling process. So as Armand pointed out, it'll show you your data gaps and data deficiencies, but it'll also consolidate all the existing data into something that you can use going forward with any assumptions and limitations that you might need to apply.
Okay, I understand.
Okay, the aim of this is to present what you understand, and we go from there.
Thank you, Matthew.
Cool. Okay, and then just to answer Antonio's questions in the chat. Yeah, your uncertainty in the definition of your conceptual model is associated with your data uncertainty. You know, if you've only got regional data and you're trying to do a site-specific conceptual model, then that's uncertainty. But it's not like a numerical model where you can do statistical evaluations and say, I am 50% uncertain on this. Yeah, it all comes down to your data confidence. Yeah, Klingiwe.
If there are no more questions about the conceptual model, can you please go through the equity solve, like how you would actually put data in equity solve, but when you're done with the conceptual model questions?
Okay. No, we'll go through it. I've got a separate presentation.
Oh, okay. Thanks.
Cool. Any other questions? No. Okay, so thanks, guys. We're done with this section 7 or session 7.